problem is about the temperature of a coffee in a cup. There is all the work and the answers right there, but that's what that table involves is the temperature in degrees Celsius of the coffee in the cup. Part A just says approximate C prime of 5 using the average rate of change between 3 and 7. So I'm just going to use those 2 points. And I just kind of jotted those down and I just use my slope formula really quickly there. We have the calculator on this one. But then you're going to get -4 degrees Celsius per minute. So that's just your easy slope formula for average rate of change. It does say show you a little bit of work there and include the units of measure, which is easy enough. Part B says use a left Riemann sum, 3 subintegrals to approximate this integral right here. So to approximate this integral, remember if we do a left Riemann sum, we start at the left side of our integral. We're going to go 100 times the distance between 0 and 3, which is 3, plus the 85 times the distance between 3 and 7, which is 4, plus the 69 times the distance between 7 and 12, which is 5. So there's a left Riemann sum. I did 100 times 3, 85 times 4, 69 times 5, and then we get the calculator to get 985 for that. Just a little quick, if it did say right Riemann sum, I would start at the right side of my interval and I would go 55 times 5 plus 69 times 4 plus 85 times 3, and that would be a right Riemann sum. So I got that first part, but then make sure you're reading the whole problem here. It says now interpret the meaning of this in the context of this problem. So this is your average value formula. That's the integral. That's 1 over b minus a times the integral from a to b. That is your average value formula, which means that interpretation, that integral represents the average temperature of the coffee in degrees Celsius, the average temperature of the coffee in the cup from t equals 0 to t equals 12 minutes. Okay, letter C gives us a new function, C prime of t, and then it tells us that's measured in degrees Celsius per minute. So that's like the rate of change there, how fast that temperature of the coffee is changing between 12 and 20. So this table is between 0 and 12 minutes. And then between 12 minutes and 20 minutes, we got a brand new function. We know what that derivative is. So it says find the temperature of the coffee at time t equals 20. Now, this is how fast the temperature is changing because that's the derivative. So if I want to go from there to the temperature, just normal C in degrees Celsius, I know I need to integrate that. And then, so I'm going to get an integral involved. However, you always have to take into account the initial temperature. So this is starting at 12 minutes. The table takes us to 12 minutes. So at 12 minutes, the temperature of the coffee in the cup is 55 degrees Celsius. So that's like the initial starting point, the initial value there. And then, so if that's where we're at t equals 12, then you're going to pick it up where you left off. So you're going to integrate that C prime because that's going to give you C. It's going to give you temperature. And then you know where you're at t equals 12. So pick up where you left off and go to where you want to go. We want to find the temperature at t equals 20 there. So what this is a graphing calculator problem. You're going to math 9 this thing in between 12 and 20. Math 9 that function. Make sure you practice that. Make sure you're getting comfortable with that. Make sure you can get that number right there. All right, and then letter D is a little bit tricky, but you gotta make sure you're thinking about this right. So it gives us this second derivative, and it says determine whether the temperature of the coffee is changing at a decreasing rate or an increasing rate. Now notice the key phrase is decreasing rate and increasing rate. The rate automatically means it doesn't say determine whether the temperature of the coffee is decreasing or increasing. Okay, it says is the rate of that temperature decreasing or increasing. So the rate is automatically a first derivative. And so we're essentially trying to figure out if the first derivative is increasing or decreasing. So anytime you want to figure out is anything increasing or decreasing, you got to look at its derivative and figure out where it's positive or negative. So if I want to know where the original function is increasing or decreasing, I look at the first derivative and determine if it's positive or negative. If I want to know where the 99th derivative graph is increasing or decreasing, I look at its derivative, the 100th derivative, to determine whether it's positive or negative. So since they said decreasing rate, increasing rate, rate is derivative, they want to know is that first derivative increasing or decreasing, which means I need to look at the sign of the second derivative and determine whether that second derivative is positive or negative. And then a big hint, they gave us that second derivative right there. So you should be utilizing that somehow. So what I got here, I put the temperature of the coffee is changing at an increasing rate since the second derivative is positive over that time interval right there. So a couple ways that you could compute, like figure that out is in between 12 and 20, you could kind of just take these values here and plug them in for the t's. And like if you go 100 minus a number in between 12 and 20, like that stuff is going to kind of stick to some positive values right there. Also, what you could do to make yourself feel comfortable with that, if you graph this whole function in between 12 and 20, like the graph is all positive, it has positive y value, so everything stays above the x-axis right there. But that's the tricky part right there. You gotta be careful with the wording on that there. So you're looking at the sign of that second derivative, and then you got, once I determined it was positive, I knew it was increasing at a increasing rate. So yeah, you got to make sure increasing rate is down there and then justify that since the second derivative is positive. Wolf spider. My brother sent me a picture of a wolf spider this morning, and I ain't about spiders, man. Spiders freak me out there. So that wolf spider, that was an intense one, man. So wolf spider.